Hello class. This would be the video for the find the exact value for trigonometric functions, which we're going to be dealing with here. Now, if you take a look, the this is the exact homework questions that you guys will be dealing with, and I hope that you guys yesterday took some time to finish these questions for the finding the reference angle. I want to go over that with you guys just really quickly before we move on. So on a separate sheet of paper, you guys should have all been dealing with how to find the reference angle, and we talked about how to figure these out on a those four quadrants and those formulas here. So for number 18, here's what you should have done. I said to sketch each angle, so you were supposed to sketch it. You're going to have something like this. This is going to end up in third quadrant because 195 degrees is going to be 180 plus additional 15 degrees. So this is 15 degrees right here. And if you take a look, the reference angle is theta minus 180 degrees for anything that is in the third quadrant. 195 minus 180 gives me 15 degrees, and that's how you're supposed to figure out also. Number 19 is 285. 285 ends up in the fourth quadrant. In the fourth quadrant, your reference angle is always going to be 360 minus the angle that you're given. So if you do 360 minus 285 degrees, so what you're going to end up getting is 75 degrees. And that is basically this portion right there. And so the answer for this would be 75 degrees. For all of these questions that you guys have, the reference angle, I'm not going to go over that too much in detail. 400 degrees, if you do that, that's going to give you 40 degrees, I believe. Negative 250 degrees will somewhere end up here. So 20 degrees, I actually need to draw a little bit. 250 degrees will end up being this to be 70 degrees. That should be your reference angle there. 7 pi over 4, that should be pi over 4. Negative pi over 4, that should still be pi over 4 for the reference angle. So these should be your 6 answers. If you have any particular questions about that, please let me know, and I'll help you out with those. Okay. All right. So with this, I am going to also go over the keynote. Let's see. Oh, yes, we are on the reference angle section. So yesterday where we left off was doing these particular questions, where I was sharing with you guys of how to figure out, doing how to find the reference angles when you're given these. Now, to go over this with you guys a little bit more in detail, negative 110 should have given you 70 degrees. The reason is negative 110 should landed you somewhere here. So if you take a look at the reference angle always is abided by the x-axis, and where the terminal side, we call this the terminal side of the angle because that's where the angle ends up being. That should be 70 degrees if this was 110 to make it to be 180 in total. So that's why your reference angle is 70. 2 pi over 3 in radians would end up somewhere here. So your reference angle should be just pi over 3. Or if you just use the formula pi minus the theta for your reference angle in second quadrant, you should get pi minus 2 pi over 3, which should just give you pi over 3 that way. Now the question what we're going to be dealing with here now is sketch each angle, then find, this is also what we've done so far, so I'll write down the angles for you there. So 300 degrees should give you 60 degrees for the reference angle. 115 should be 75. Negative 3 pi over 4 should just be pi over 4 for your reference angle. Okay? All right, so now what we're going to do is find the exact value of each trigonometric function. So for these questions, what you're going to be dealing with is not only are you going to be having the sine, cosine, tangent, but you're also going to have angles that is no longer restricted to this boundary where the angles are always going to be between 0 and 90 degrees. If I gave you sine of 30, cosine of 45, tangent of 60, we all knew how to do that from the previous table, and we have those data for it to show. For these questions here, what you're going to do is you're going to actually take the value of the angle first, but you always want to convert it into what we call a reference angle and then compute those trigonometric function as it seems. So first of all, 240 degrees, that's your homework questions from yesterday. How do we convert this into a reference angle? Well, first of all, you sketch it. Well, you don't have to sketch it. I'm not going to abide by that policy. All children are born artists. For this case, you're just going to have to find the reference angle as quickly as possible. If you're one of those visual person like me, then you might want to draw something like this. Your terminal side ends up in the third quadrant, which means I am going to take a look at this angle right there. So 180 degrees, and then it's additional 60 degrees. So I know the reference angle is 60. Or follow that formula where theta minus 180 degrees, 240 minus 180 is give you 60. So your reference angle is 60. Now that means it's cosine of 60 degrees. That's going to be the same value as cosine of 240 degrees. Now cosine of 60 degrees from the previous slides here, it gives me 1/2. So I'm just going to write cosine of 240 degrees is 1/2. Now if you write it to me this way, you're going to get the question wrong. Okay, there's one last part that you have to check. Check for sines. The reference angle is only good until you find the value. Okay, once you find the value, that's all fine and dandy, but you have to check for sines. Remember, guys, ASTC, those acronyms that I taught you yesterday, all students take calculus. You end up in the third quadrant. If you end up in the third quadrant, it means that only tangent's positive here. But we're talking about cosine. So what does that mean? All the other trig function turns out to be negative values. And even if you were to take a look at your unit circle here from yesterday, we find out that 240 degrees, which is this one, you're both x and y, they're both negative values. And lo and behold, it becomes negative 1/2, right? So if you do not have the reference angle handy and you want to figure this out on your own, you just use the reference angle to find out the numerical value, okay, numerical value of the question, and then because you have to check for sines, third quadrant means cosine is negative. So then you rewrite this equation, cosine of 240 degrees is negative 1/2. You just have to put a negative sign in front of it, and that is just going to be your answer right there. That's all I'm looking for. Okay, let's take a look at these two questions, and hopefully that you're able to do these without a unit circle chart. But what I would like you to do is I would like you to show your work and do these questions on a separate sheet of paper, and then if you want to show it to me, that's great, but work on it right now and pause the video. Okay, and play it again once you're ready. Assuming that you guys have already finished this, now let's go over this together. Cosine of 135 means that I need to find the reference angle of 135. The reference angle here will end up being 45 degrees. So I'm going to do the same thing as saying cosine of 45 degrees, which ends up being root 2 over 2. Am I done? Absolutely not, because I need to check for sines. Always. Check for sines should be your last step. Notice my terminal side ends up in a second quadrant. Second quadrant means ASTC. Sine is only positive. So cosine of 135 degrees, because that's the question that they're asking you to solve for, should be root 2 over 2, the same value as cosine of 45, but you just have to put a negative sign in front of that. And when you go back to your chart, this should be a good way to check your answers only. For the sake of checking your answers, 135 cosine is negative. So you know you're right. Next question, it's in radians, but it doesn't change the fact that it's going to be dealt the same way. Tangent of 5 pi over 6, first of all, 5 pi over 6 in reference angle in radians should give you pi over 6 because I end up here. That's pi. Ooh. That's 5 pi over 6. Reference angle should be pi over 6. So that's the angle that we're going to be using. If you want to convert this into degrees, which should give you 150 degrees, that's also perfectly fine. 5 pi over 6, so we're talking about finding the tangent value of pi over 6, which should be equivalent to saying root 3 over 3, I believe. Because that should be the same thing as saying tangent of 30 degrees, which should be root 3 over 3. Now, again, we want to check for the sines. Your last step, check for sines always. And then what you're going to get is that you're in the second quadrant for your terminal side, ASTC. Sine is only positive here, so tangent must be negative. So therefore, your final answer, 5 pi over 6, please rewrite your original equation, is equal to negative root 3 over 3. Just put a negative sign in front of it. Okay? All right. So for these questions, find the exact value of each trigonometric function. Secant is the only one I'm going to ask you to skip for now. If you guys want to do this question, secant, we haven't talked about it, but it's what we call 1 over cosine of theta. So whatever the cosine value is, so let's say, for example, cosine of 120 degrees ends up being triangle over circle. secant of that exact angle should be circle over triangle. You just have to reciprocate it. That's the only thing that you're going to be doing. Okay? So for these four questions, I'm going to give it to you as a guided practice. Practice it on your own. If you want to upload them along with your homework questions, that's great. So I can check them with you. But really, what I'm really looking forward for is these 5 questions are going to be for your homework. Okay, make sure you draw them and show me the work for each of these. And please upload them by 4 p.m. today. Okay, and thank you. Have a good day.